next thing I want to look at is term-by-term differentiation of a power series and how we can use that. Let's consider the derivative of cosine x. We should feel pretty comfortable that the derivative of cosine x would be negative sine x, but we're actually going to prove this using power series. So we start by using the Maclaurin series for cosine x. So I'm going to look at the derivative of 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, etc. Since these are just all powers, in order to take the derivative, I would need to bring the exponent down and subtract 1. The derivative of 1 is 0. And then the derivative of x squared would be 2x. So when I take the derivative, I get 0 minus 2 times x over 2 factorial plus 4 over x cubed over 4 factorial minus 6 times x to the 5th over 6 factorial, etc. I can then simplify these terms. When I do, I get negative x plus x cubed over 3 factorial minus x to the 5th over 5 factorial, etc. And from there we can see that this is very, very similar to the Maclaurin series for sine of x, except that the signs are different. The Maclaurin series for sine of x said x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Thus, this is the same as negative sine x, which is exactly what we wanted it to be. Let's do another one, this time with the derivative of e to the x, which we know should be e to the x. We know the Maclaurin series for e to the x looks like 1 plus x squared over 2 factorial plus x3 over 3 factorial plus x to the 4th over 4 factorial, etc. So let's take derivatives of these. Taking derivatives gives me 0 plus 1 plus 2 times x over 2 factorial plus 3 times x squared over 3 factorial plus 4x cubed over 4 factorial, etc. I can then simplify these terms. And when I do, I get 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. Which is exactly the Maclaurin series for e to the x. Therefore, the derivative of e to the x is equal to e to the x. Now that we've looked at differentiating power series, let's look at using them for integration. I want to look at the integral from 0 to 1 of e to the x squared dx. We know the Maclaurin series for e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. Therefore, the Maclaurin series for e to the x squared should be 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial, etc. So instead of trying to integrate e to the x squared, which we can't do with analytical methods, we're going to integrate this Taylor series. So I now have that this is the same as x plus x cubed over 3 plus x to the 5th over 5 times 2 factorial plus x to the 7th over 7 times 3 factorial, etc. And we need to evaluate between 0 and 1. Since this is an infinite series, it might be difficult to figure out the exact value when I substitute these numbers in, but we're just going to use the first 4 terms to get an approximation. When I stick 1 into the first 4 terms, I get 1 plus 1/3 plus 1/10 plus 1 over 42. And when I stick in 0, I get 0. Which gives me approximately 1.457.